Okay, in this example, I'm going to show you an example of dimensional analysis for a specific type of problem. What we're going to do here is we're going to take the density of a material and we're going to convert it from the CGS system, which is centimeters, grams, and seconds, and convert it into the MKS system, which is meters, kilograms, and seconds. So CGS is a way of thinking about units. C stands for centimeters. G stands for grams. And S stands for seconds. And we're going to convert that into what's called the MKS system, which is meters, kilograms, and seconds. So CGS into MKS. Okay? Density is a good example of this conversion. So density is mass divided by volume. And these values that are given in the table here, I'm going to pick one of these. I'll pick one of the metals. Let's pick gold, for example. Gold has a density in the CGS system of 19.3 grams per centimeter cubed. Now let me make one point about the centimeter cubed as a volume unit. Is 1 centimeter cubed is the same as 1 milliliter. They're the same quantity. I won't show that here why that's the case, but you can find that online. But we're going to convert grams per centimeter cubed into kilograms per meter cubed. So let's use gold as an example. So I'm going to write down that the density of gold is 19.3 grams divided by centimeters cubed. And the first step I'm going to do is I'm going to convert the grams into kilograms, and here's how we'll do it. 1 kilogram, remember kilo is a prefix. It means 1,000 or 10 to the 3. So 1 kilogram is 10 to the 3 grams. And now we have a conversion factor that we can use to convert grams to kilograms. So 19.3 grams per centimeter cubed. And then we're going to convert this to kilograms. So 1 kilogram divided by 10 to the 3 grams. And so that is going to get rid of the grams, and we'll now have kilograms per centimeter cubed. So 19.3 divided by 10 to the 3 is the same as 19.3 times 10 to the minus 3. And this is kilograms per centimeter cubed. I'm sorry, yes, centimeter cubed. Okay, kilos, sorry about the writing there. 10 to the minus 3 kilograms per centimeter cubed. If we are dividing by 10 to the x, that's the same as multiplying by 10 to the minus x. So dividing by 10 to the 3 is the same as multiplying by 10 to the minus 3. Now we need to do the conversion from centimeters cubed into meters cubed. So a centimeter, centi is 10 to the minus 2. So a centimeter is 10 to the minus 2 meters. Now we use that. So I'm going to rewrite our sort of intermediate result here. 19.3 times 10 to the minus 3 kilograms per centimeter cubed. And then I'm going to multiply that by, we want to get rid of the centimeters. Centimeters is down here, but let's take a look at what we have here. This is a centimeter, and a meter, we want to go from centimeters cubed to meters cubed. So we have to cube both of these sides. So I'm going to cube this, and I'm going to cube this. And that'll give us centimeters cubed and meters cubed. So now, which do we want? Well, we want to get rid of centimeters cubed, which is in the denominator down here, so we got to put it in the numerator up here. Now, 1 centimeter cubed is a centimeter cubed, because 1 cubed is 1. However, on the right side here, 10 to the minus 2 cubed is not 10 to the minus 2, it's 10 to the minus 6. So this is 10 to the minus 6. And then meters cubed is just meters cubed. Now our centimeters cubed cancel, and now we've got kilograms per meter cubed. So now how do we deal with this mathematically? We have 19.3. How do we deal with the powers of 10? Times 10 to the minus 3 divided by 10 to the minus 6. I'll leave the units out for now. Well, how do we deal with 10 to the minus 3 divided by 10 to the minus 6? If you recall from powers of 10 lecture, you subtract the exponent in the denominator from the numerator. So 10 to the minus 3 divided by 10 to the minus 6 is equal to 10 to the minus 3 minus a minus 6. So that's plus 6. And so that would be 10 to the 3. So our powers of 10 end up being 10 to the 3. So now we would have 19.3 times 10 to the 3. And now we would have the units of kilograms divided by meters cubed. And so 19.3 times 10 to the 3, well, 10 to the 3 is 1,000. So this is really just 19.3 times 1,000. So that's 19,300 in decimal notation, kilograms per meter cubed. So if you take a look at the value at the end of this conversion factor, and this is a pretty involved conversion factor, 19,300, we went from 19.3 grams per centimeter cubed, or grams per cubic centimeter, to 19,300 kilograms per meter cubed. What happens is, in the units of kilograms per meter cubed, we're measuring a very large volume. A meter cubed is a meter by a meter by a meter. That's a big block, so that's going to weigh a lot. If you have that big of a block of gold, it would weigh 19,000 kilograms. However, if the volume that we're measuring is only a centimeter cubed, well, that's a small volume. A centimeter is less than an inch. So imagine something smaller than an inch as a cube. That wouldn't weigh nearly as much as a meter cubed. So the density in grams per centimeter cubed is relatively small numerically compared to kilograms per meter cubed. Okay. So there's an example, and you can take a look at that. And so in conclusion, if you want to know what the density of a material is in kilograms per meter cubed, and you know what the density in grams per centimeter cubed is, you just multiply by 1,000, and that'll give you the value there.